Hi, my name is Catherine Medina de Villiers, and welcome to Random Variables. So, what do I have for you here today? Again, we're going to be looking at random variables to generate possible values that we can use to help in certain simulations or evaluate code segments. Again, on the AP exam, on your sheet there, you're going to see references to randomization via parameter A comma B or the block code. And remember that those numbers are bookends and those numbers are included in your set. So again, if you have something 1 comma 6, you're dealing with numbers 1, 2, 3, 4, 5, and 6. Okay, let's hop to some examples. Cut to the chase. So let's say you want to write a piece of code that will simulate a coin flip. How would you go about doing this using randomization? So I want you to put the screen on pause for a little bit, write down some notes or some pieces of code, and let's see how it compares to what I got. Okay, hopefully your example looks something like this. At first, you're going to go ahead and you're going to use the randomization because it's the randomization that's either going to give you, in this case, a 1 comma 2, 1 or 2. So I'm hitting the range here, 1 comma 2, because when I'm flipping the coin, I only either have heads or tails, two states, two choices. Okay, so flip is either going to have a 1 or a 2. Now, flip has 1, I'm going to display heads. I don't need to compare for flip equaling 2 because if it was 1, if it's not 1, then by logical deduction, it's 2, and then it's tails. So this is one way to approach the problem. But let's look at another problem where we just don't have two states, and they're not all equal. Like heads and tails was 50-50. So let's look at a spinner now. And if you look at this spinner, I have 8 equal sectors, okay? 8 parts of this spinner equally divided. But what's interesting is that green has 3 of the sectors, blue has 2, red 1, orange 1, and purple 1. How would you go about writing a piece of code to simulate this spinner? Put the screen on pause, write something down, and let's see how it comes out. Okay, welcome back. Well, hopefully when you wrote your block code here, you did a randomization from 1 through 8, but you have to remember we're going to have to upfront or upload that green. So I went ahead and I looked at the results and I made it inequality. So if the number coming out of the randomization was either 1, 2, or 3, I went ahead and displayed the green. So it gave it its proper proportionality here with the spinner. Then I assigned 4 or 5, 2 numbers to blue because blue's on 2 spaces. Then 6, 7 to one of the numbers, red and orange. So one of those numbers got red or orange. And then what else is left? Well, 8. And we're just going to say an else and sign purple to it. So it provides a true reflection of what's going on here with the spinner. So let's recap. Okay, remember we're using randomization of predefined pieces of code to produce our randomization, and they're giving us equal results, and the A and the B are inclusive. So now let's look at another question. Let's say you want to create a magic 8-ball program, and not to date myself, but these were really fun when I was little. So you want yes to show up 50% of the time. So looking at the choices here, A, B, C, or D, what are the possible code segments you can use from that randomization code that would be able to give you a result of yes 50% of the time? So with that being said, put your screen on pause and then come back. Well, welcome back. Hopefully you said A, C, and D. And so let's cut to the chase. Look at randomization for B, 1 through 100. If I say it equals 50, I'm only saying when only that one number out of 100 shows up, give me a yes. That's totally what we don't want. We want it to come up 50% of the time. So I could still use a range of 1 to 100 and say less than 50. I'm getting a 50% chance there. But what if, I don't want the range to be so big? Could I still have a smaller range and still get to 50%? And sure enough, I can look at randomization of 1 to 10. And if I'm 5 or less, I've got 50% of the possible numbers coming out. And I can do greater than 5, going from 1 to 10, and still get 50% of the numbers coming out. So I still get what I want, a 50% chance of yes showing up. So with that being said, let's look at this question. So now we're looking at a spinner again. We have a total of 6 equal segments, but I want you to create a piece of code with the smallest range of numbers reflecting this spinner. So if you could put the screen on pause and we'll go back to this one. Hopefully you said a randomization of 1 to 3. So granted, you have 6. Let's look at the spinner closely. You have 6 sectors and 2 green, 2 blue, 2 orange, right? Let's think about it. Each color has a 1 out of 3 chance, really. Okay, 2 out of 6, reduce your fraction 1 over 3. So you using that mathematical deduction here, logic, you can then use a randomization 1 comma 3, that being your smallest range. And again, assign it to spinner and spin 1, green, 2, blue, else orange. Okay. All right. So what should we take away from this lesson? We use randomization. We use random variables to express possible values that we can use in our code segments. Okay. Now, this can be expressed with a parameter, a comma b, or we can use it in block code. But always remember, the bookend numbers are included in your range and the range is discrete. So I want to thank you for attending today's class with me. I hope you really enjoyed learning about randomization with our code.